All right, welcome back. So for the next part of the inventory, what we're going to do, um, I like to have, I would like to have, instead of blueprints and uh, files to run my items, I would like the ability to have thousands of items, right? If you want to be able to have all these items, we can try to keep them nice, neat, and organized inside data tables. So I would like to be using gameplay tags with data tables, and then we can retrieve all of our item information from that. So what that means is we're going to come back to our C++s, and in the inventory, we're going to make a new class, and it's going to be empty, and it's none, and we're just going to call it item types, and that's it. So we're going to create item types. We can get rid of the default destructor. We don't need that. And we actually don't even need any of this. And I can close the CPP file. We're just going to leave it like that. And then the next thing that we're going to want is back in the inventory, we are going to want another data asset. And I call this item types to tables. Item types to tables is going to be real quick and easy to set up. We're just going to make a public section real quick, and inside of it, it's going to be another T map, and it's going to be of F gameplay tag. And we need to add the include for, and then the value is going to be T object pointer of a U data table. And this is going to be tags to tables, and a U property of edit defaults only. And that's the only thing we need to do in item types to tables. Okay, so now we have item types. Well, we're going to make a struct, and this is going to be our, what I'm going to say is U struct. Oh, and it's not giving me the generated, which means I need to include item types.generated.h. And then now I can say ustruct, and I can say this is an F master item definition. I can say that, and we're going to make all of this blueprint type. You're going to want all of this blueprint type and make everything exposed to blueprints. So the first thing we need is going to be an F gameplay tag, and this is going to be the item tag. Property edit defaults only, blueprint read only. And then we're going to want an F text, and this is going to be the item name. U property edit defaults only, blueprint read only. Then we are going to want a T object pointer of a U texture 2D, and this is the icon. U property edit defaults only, blueprint read only. We are going to want another F text, and this is going to be the description. This is property edit defaults only, blueprint read only. And you know what? Underneath the item tag, it's up to you how you organize these. I'm going to put it right here. I'm going to do an int32. This is the item quantity. And we're just going to give this a U property of blueprint read only. I don't want to give blueprints the right to write the item quantity. That should all be handled within C++ in the tag map. So we're just going to read this. We're going to leave all the writing of quantity and stuff up to blueprints. So that basically in editor, when we do this, this won't even be an option that shows up. It won't show up, but then when we go to use this data, it'll be available in blueprints for us to be able to read it, right? So then what we can do to start, because I want to get into some kind of decent item, is so above the master item definition, right? So the master item definition struct needs to be the lowest struct in here, right? We're going to make another struct, and we're going to call this F consumable props. And in there, we're going to have a T subclass of U gameplay effect that we can do a forward declaration. And this is item effects class. New property, edit defaults only. And we could do blueprint read only. I've never used it in blueprints, the item effect class, but we could do that. We'll see how that works. And then we can do a float. And the float is the item effect level. View property, edit defaults only, blueprint read only. We'll see it there. And this needs to be blueprints type. And now that we do that, what I'm going to come down here is in the master definition, I'll make an F consumable props and just call it consumable props. And then view property, edit defaults only, blueprint read only. Now I did forget too, one of the important thing here is our master definition. We need to put a colon because we need to inherit from an F table row base. Now that we inherit from an F table row base in the F master item definition, now back in the editor, I can make data tables out of master item definitions, right? So I have this, I'm going to make this into a data table, but I want to run this all off gameplay tags. So we're going to close items for a second. I'm going to close all these for a second. I need to come back to, we're going to go back to our libraries, and in our static function library, we're going to write ourselves a very nifty, I was taught this, very nifty, very flexible getter, which is really kind of cool. So what you could do is you could say template and then type name T, right? And then it's going to be a static T pointer return called GetDataTableRowByTag. And that is going to take in a U data table pointer that we'll call data table, and then it'll take a const f. No, I can't do const. Excuse me. We'll just take an f gameplay tag, and that's called. Oh, excuse me. We need to include gameplay tag container to use it, and this will be item or just tag, and we can generate a definition. We can leave it here, that's fine. All we're going to do is just return, and we're going to do data table, say find row with class T, and the first parameter is going to be tag dot get tag name, and then the next one is context string. Well, we'll just make an F string that has nothing in it. We don't need a context string. So now that we have this get data table row by tag, right? I can throw any data table class that I'm looking for in here, and it will return that to me, right? So now I have this getter. Now I'm going to come back into the inventory component, and we are going to come into the public section, and we are going to write ourselves another function. And this is going to be an F master item definition, and we're going to add an include. You see, in order to use this item, we have to include it in the header, right? And instead of bloating the inventory or any one specific file with with the item definition, and then let's say I need to use the item definition in another file. I don't want to have to copy the entire inventory component header just to get the item definition header, right? So we just make the item definitions its own header file. So anywhere we need to know what an item is and we need to include it, we could just stay at just the definition, that header, and try to keep our overall other headers down. So this is going to be an F master item definition return, and we're going to call this GetItemDefinitionByTag, and this is going to take a const f gameplay tag reference called item tag, and we're going to give this a U function, and we're going to mark this as blueprint pure. Okay, so now we have this blueprint pure function. What we're going to need to do is, remember, down in the private section, we're going to make a T object pointer, and we're going to bring in the U item types to tables, that data asset, with a forward declaration, and we're going to call this inventory definitions. And we're going to make this a U property, edit defaults only. So now we have inventory definitions. So in GetItemDefinitionByTag, what we're going to do is we're going to check F, that inventory definitions is valid, and if it's not, we're going to crash the engine and say no inventory definitions inside component %s, and then we can say get name, save this. So now if we get past this, that means someone has given us inventory definitions. And then we can loop, we can say for const auto reference pair, the inventory definitions has the tags to tables map, remember, tags to tables, and then this is another map, so I do const auto pair. So we just remember the pair.key was the gameplay tag, and the pair.value was the data table pointer. So now we can say for tags to tables, we're going to ask ourselves if the way gameplay tag searches work. I'm going to say if item tag dot matches tag pair.key. Now, if we look at what matches tag, come on, see if it'll highlight. It says, determine if this tag matches tag to check, expanding our parent tags. So A.1 matches tag A will return true, while A matches tag A.1 will return false. Right? So what that means is our item tag, when we want to get this item definition, our item so far is item.consumable.health potion. And then we have item.consumable.mana potion, right? So what we're going to say is get item definition by tag. We're going to pass in the full item tag. So we're going to say, okay, item.consumable.health potion. And we're going to say, does that match the tag? And we're going to break down this tags to tables by the parent category. So we're going to define items.consumables, and we're going to say items.consumables lives with this data table inside these tags to data tables, right? So we'll see exactly how it works, but essentially this is going to ask, hey, does item.consumable.health potion, does that match the tag item.consumable? And then if it does match that, then we can return a dereferenced U RPG ability system library, call the function GetDataTableRowByTag, and the template that we're looking for is the F master item definition. And then the first one that it needs is the data table pointer, which is our pair.value. And the next one it needs is the gameplay tag, which is the item tag. And if that fails, then we just need to return an fmaster item definition default constructed, um, and that's it. Oh, and I believe, yes, we can make this const because we are just getting, so we can make this const. So now that we have this ability and the need to do inventory definitions and what, or we're going to crash the engine, why don't we set up the asset? Let's rebuild, recompile, and set up the data assets. Now that we're back inside the editor, let's take a look. We need to come to the third person, blueprints, and then we can come to data, excuse me, because we're making a data asset, right? And we'll take miscellaneous, make a data asset, and this is items types to tables, and then DA inventory definitions. We can make, here we go, a gameplay tag. So we're only going to search by the item consumable. So that means all of our health potion, mana potion, everything that we send through is going to match to this. But we don't have any data tables. So let's go into that. Let's go data, and we can make a new folder called inventory where we can put our inventory definitions, and then we'll make a new folder called data tables. And inside here, we can come and say miscellaneous and data table right here. And in the pick row structure, we can go find master item definition is here now. So we can say, okay, so now we're going to say DT consumables, right? So here we go. We're going to add a row. Now the key to making all of this work is your row name must be spelled exactly with no typos, exactly how the name of the tag is written. So it is item.consumable.health potion. And then now we have our struct information to fill out. So the item tag is going to be item consumable health potion. And the item name is going to be health potion. And then the icon, we can just do this, and the description is restores health. Now, there's also the consumable props, which is the item effect class and the item level. Well, we're going to have to come up with some way to use it, right? But in the meantime, we can take a new row and say item.consumable.mana potion. And then mana potion. And we can put the green guy, and this says restores mana. So at least we have a data table now to go match. So now our item, everything that is a consumable item now will exist on this data table, right? And then anytime I need that item definition, I can just pass through the gameplay tag for the item, and it will run through all of our inventory definitions, all of our categories, and it will pre-filter all the data tables that aren't in the primary category, right? So weapons, armor, loot, crafting goods, building materials, all those different categories, it will just filter all of those out and skip all those data tables and not even bother looking through them. It will just quick filter through and say, okay, find me just a data table that has only the consumables, okay. And then it searches the data table row appropriately. So if you categorize and you break up your items into these categories enough, this is a pretty efficient search. So now that we could do that, what's the next thing that we're going to do? The next thing we're going to do is we're going to make a use item function, right? So we have void. Well, now we have consumables. Now we need to make a void use item. And this is going to be a const f gameplay tag reference called item tag and int32 num items with no default. And we're going to make this a U function blueprint callable as well. And then, just like add item, we don't want to let clients use items, do we? Without the server. So we're going to say void server use item and const f gameplay. I bet you know what I'm doing. Gameplay tag reference called item tag and int32 num items. And this is the U function server reliable. Generate the definitions for these. I'm going to try to organize this a little. I'm going to bring this getter down here, and we're going to say that's add item and server add item, and then package inventory, and then on rep. So then we'll say use item. Now, in use item, imagine I'm going to do this. I'm going to make an actor pointer called owner, and I'm going to set it equal to get owner. And then I'm going to say if not is valid owner return, and then I'm going to check if not owner, and we're going to ask has authority, and we're going to say server use item, and we're going to pass along the item tag and the num items, and then we're going to return. Holy cow. And I bet you know what I'm going to do in server use item. I'm just going to call use item, and we're going to pass along the item tag and the num. Okay, so now what the server is going to do is we're going to get our item. We're going to get an F master item definition. We're going to call it item. And we're going to get that by saying get item definition by tag, passing in the item tag. So now that we have our item, we could just say if U ability system component pointer with other ASC is equal to U ability system blueprint library, get ability system component, passing in the owner. Oh, excuse me. So if we can grab an ability system component off the owner, we can say if item dot consumable props dot item effect class. And then I don't know if you could just, yeah, you could say if is valid. Okay, it'll reformat it that way. You could say if is valid the effect class, right? So not all of our items have to be effects, right? We're going to keep the same master item definition for all the different categories. So that's why I like to break up the little subsections into their own little mini structs, is because it'll keep that data collapsed so you only get to look at what section you want. So right now, if it's an item effect class is valid in there, then we know it's a consumable, right? Because the consumable props is filled out. Well, what do we do with an effect class is we take the other ASC and we do the same thing we've done everywhere else. We apply a gameplay effect spec to self, which requires a gameplay effect spec. So we get an f gameplay effect spec handle, which we call spec handle, and set that equal to the oh, why did I say other ASC? Excuse me. I should call this owner ASC. That's what I meant to do. So I'm used to, sorry, but we'll call it the owner ASC, and we'll say make outgoing spec. And the class is the item dot consumable props dot item effect class. And then the level we put in there as the item dot consumable props dot item effect level. And then we can make an f gameplay effect context handle called context handle, set that equal to owner ASC make effect context, and then we can put our context handle right there. Oh, and remember, these can be const. And then after that, we're just going to dereference the spec handle dot data get. And then it's a consumable, right? So now we've used this item. So we are going to say add item, and we are going to pass in the item tag and we're going to add -1. We're going to use it. And for right now, looks like item can be const. So we'll see about that. Okay, so how can we test this? What we could do is simply right here say gEngine. We can add an on-screen debug message. Key of -1, a display time of 5 seconds. And we could say F color. What are we going to make it? We could do magenta. And our message is going to be F string print F with text macro being item used. And then we can say %s. And then we can just come out here and put a comma, and then we can put star item dot item tag dot toString. So now whenever we use an item, and we can definitely put server item used, right? Because we can do server item used, excuse me, because again, if we don't have authority, we're just calling server use item, calls use item, then it'll get down here. And then keep in mind, now that we're removing an item, right, we're still calling add item, but it's -1, but we're removing an item. So that means back up here, add item will get called. It will subtract the number of items from it, package it, replicate it, and this should come back up to us, tag added, quantity added, every time we use an item as well, right? So let's recompile and go back into the editor. Okay, so now we're back in the editor, and we are going to come into consumables, and in the consumable props for the health potion, what I'm going to do is just do the pick up health up, and the effect level, I could set that at 1. And then the mana potion, however, I don't have anything that's going to restore mana. So if we come into the abilities, and then in the test, I could make a gameplay effect. I can say GE test add mana. And I'll show you too, when you do has duration, right, you can actually make it look pretty smooth on the screen. So let's do this. Let's give it I'm going to show you a little trick. So we already went over that if you put a period in here of 0.5 seconds, we already went over the execute periodic defect on application, right? But what you can do, instead of unchecking this and then making like 5 seconds for every 0.5 seconds, what you can do is actually check this and then reduce this by 1, right? And then say 4.5 seconds. So now it'll execute the moment that you pick up and then only 9 more ticks. So it'll still heal the 10 ticks essentially, but it'll just do it that way. So you could do that if you want an instant effect. So let's try that. And then we'll do 3 seconds, but we're going to make it every 0.1 seconds. And we'll see how nice and smooth that will make our mana increase if you want. So what are we going to do 30 times? Well, we're just going to add 1. Right? Because this is going to be 30 ticks, and we're just going to add 1 at a time. So in here, we can say test add mana at level 1. And then now I have all of this here in these. I need to come back into the player controller, because the player controller has the inventory component, and inside the inventory component we have to put our inventory definitions. Remember, we made an assertion, and that'll crash the engine if we don't do that, right? So now on 1 I can add myself these items, and then now I can say keyboard 2, we can get the inventory component and we can say use item. And we can flip flop and do the same thing. Oops, I want to do highlight those and duplicate. So I can make the mana potion. I should also set the default value of use item to 1 now that I think about it, but I didn't. I was thinking ahead and I got away from myself. Oh, excuse me, I didn't hook up the inventory component there. So number 1 will add it all, and then number 2 will remove it all and apply the effects. So let's see how this works. We're gonna hit play, and I'm just gonna go, I'm gonna close this. I'm just gonna go straight to the client, right? Because we're here for multiplayer. Well, on the client, I can pick these up and take damage, right? So now I'm missing health and I'm missing mana. So I can give myself a health potion, and now I have 1 health potion, 1 mana potion. Well, I'll give myself 2 and 2. Well, now I'm going to hit 2 once those go away, and nothing happens. So yeah, we're going to push number 2 on the client, and nothing is going to happen. Now, why not? And that is because I forgot to take into consideration, and if you noticed before me, I forgot to take this into consideration uh, a long time ago, and that's my fault. We are trying to call GetAbilitySystem component on the owner of the inventory component, which is our player controller, right? So what we need to do is come back to the player controller. And in the player controller, we also need to inherit from the iAbilitySystem interface. And in the public section, a virtual uAbilitySystem component pointer return GetAbilitySystem component const override. Well, we're just going to honestly chain these. I just need to return uAbilitySystem blueprint library GetAbilitySystem component from getPawn. GetPawn is our player who also has the ability system component, right? But the player has the actual object pointer on there. So we can use it on our pawn. So now the player controller is just going to return the ability system component that is being got from the pawn. So now let's recompile and try again. So now we'll give it a shot now that our player controller should have access to a reference of the ability system component. So I took some damage. I have a low mana. I've added a couple of those to that. I'll let those messages go away. And then, oh, server item used, health potion. And now my health went back up. And then I can press 2 and it used a mana potion. And if you see, my inventory is now back to 1 and 1. And then if I use a health potion again, you can see it just kicked it out. The only thing in the array now is the mana potion at 1. Because remember, when we're doing the map packaging and reconstruction, we're only packaging things in the map if their value is greater than 0. So now it basically just erased health potion from the array. And then if we push it again, I can use the mana potion again, server item used, but now it's completely empty. And then we have to go back to adding 1 and 1, 2 and 2. And then you can use 2 and 2, 1 and 1. So now our data table is filled up with all the information that we need. And we're able to just grab any row out of any data table that we define as an item, and we can keep all of our items instead of blueprints and whatnot. We can keep it all nice and tidy in organized, categorized data tables. And because this is C++, the search times are just are very efficient. So I think that's a good place to stop for now, and we'll continue next time.